Hello everybody, how's it going? My name is Leo, aka Knockdev, and today I would like to teach you guys some basic math stuff for shader graph and shader development inside of Unity. So once again, very conceptual episode. We're not going to be diving into too many experiments, but it's very valuable knowledge. So let's jump right into it. So today I was thinking about going over the 1 minus node, addition, subtraction, multiplication, the sine node, and remapping stuff. And the reason why we're going to cover so many math stuff is because we're going to be using the sine wave to explain all of it. So let's jump straight into it. So the first thing we're going to do here is that I have this simple shader and a simple quad. So let's go into our shader here and let's just add a sine node, right? And let's jump right into the alpha. Let's jump that straight into the base color. And you guys are going to notice that nothing is going to happen. It's just going to be a black square. Now, why is this happening? Well, let's jump into this thing so we can see what's going on. All right, cool. So this is a sine wave, and I'm using Desmos, which is a tool that shows like math stuff. And let me take a screenshot here so we can better explain this. Let's go. Where's my Photoshop? Okay, my Photoshop is not opened up. I'm sorry. But if you guys notice here, you guys are going to notice that the very start here is at 0. So, of course, 0 is blackness. So, of course, 0 means black. By the way, let me close Discord before we get any messages. So, this is why our shader is just black. Well, how do we change that? Well, in the sine wave, when you add a value to a sine wave here inside of the sine operation, you can add the time of the operation. So here I made a slider that represents time. So let's play the slider. And as you guys can see, the sine wave is moving. And when the sine wave moves, you guys are going to notice that if we're always looking at it from this point of view, right? Sometimes the value is going to be really high at 1, then it goes back to -1, then it goes back to 1 minus 1, 1 minus 1. It just, you know, swaps between them, ping-pongs between them. So let's get this value back to 0. All right, so thankfully, Unity provides us with a time node. So let's plug in the time node in here. So let's get ourselves a time node, and let's plug the time into the sine. And you guys are going to notice that now, if I go to my black square here, it is going to flash white. It flashes white, goes back to black. Flashes white, goes back to black. And one interesting thing as well is, you guys have noticed here that I made this point, which is at 2 pi 0. Why? Why is this point right here? Why is it right here, Leo? Well, very simple. Because if you guys notice here, our sine wave starts at 0, goes to 1, goes to -1, and then it goes back to 0. So it takes approximately 6.3 seconds. This shouldn't be 1 second. This should be 1 loop. Sorry. My bad. So it takes 6.3 seconds for it to finish 1 loop because we use the rate of 2 pi to complete a full loop. So this is the full loop of the sine wave that Unity uses. So if we go back here, and if you were to take a stopwatch, you would see that it takes 6.2 seconds. But here's the thing. Let's now dive into multiplications and stuff, right? So, for example, I have this 1 here, which is a multiplication value. So let's multiply everything by 2. And you guys are going to notice that now our range is no longer between 1 and -1. Now it's between 2 and -2. So let's do exactly that. Let's go here inside of Unity and let us multiply it by 2. And you might say, well, Leo, how am I going to know if it's working? Well, values outside of 1 in Unity, in shader development, are taken as brightness. So if something is above 1, if something is above the ceiling of 1, it is treated as brightness. So if I have a lamp with a value of 100, it's going to emit 100 light information. So observe. If we go back to our scene, it's going to be black, and then it's going to go into white, and then it's going to flash bright, and then back into the whites. So it's black, and now white, and now it's very bright. You guys can see that it's bleeding through. You see that the colors are bleeding through. Oh my god, the colors are bleeding. Want another example of that? Very simple. Let's drag a texture. If I drag this texture here, put it here, you guys are going to notice normal, right? If I add the texture onto itself, we're going to have the texture plus the texture information again as brightness. And now you guys are going to see that the colors are bright and they're popping off and they're blooming. And this halo of color around them is the bloom. Now, you might say, well, Leo, this is cool, but I don't want bloom, you know? I don't want it. I want my texture to go like at a maximum of 1. Well, very simple. So what you can do is use the clamp node, right? So what the clamp node does is that anything below 0 is going to be turned into 0. Anything above 1 is going to be turned into 1. All right, so let's drop this here, and you guys are going to notice that now when we go into the whites, we don't bloom anymore. We don't pop off the colors. All right, so this is clamp. But you are a guy who's really into mathematics, and you want, for example, I don't know, you want things to be, you still want your range to go from 2 to -2. So you want a range difference of 4 on your peaks and depressions, but you want to raise it in such a way that the minimum values are 0. So now, instead of going from 2 to -2, it is going to keep the same rate, but it's going to go from 4 to 0. Well, my guy, I have just a mathematical operation for you, and that is remapping. So before, when we clamped, let's do the clamp again. So before, when we clamped, anything below 0 was turned to 0, anything above 1 was turned to 1. Now, when we remap, we're not doing that. Now we're stretching things from -1 and 1, in this case, -2 and 2, and we are stretching it. We're like repositioning it in such a way that it goes from 0 to 4. It's still the same rate of change, but now the numbers are in a different position. So let's save this, and now look at that. Oh my god, 4 brightness, it's so bright. It goes to 0, and then it goes back to 1, and then 2, and 3, and 4, and then 3, and 2, and 0 again, and that's how it goes. All right, so this is remap node. But, here's a little trick of the trade. Let's say that you want to clamp your values. But you say to yourself, Leo, clamp is too expensive. Clamp is way too expensive. I don't want to do that. What I want to do is, I just want, you know, I don't care necessarily about my values being repeated, you know, and going through the operation and saying, oh, if it goes above 1, turn into 1. If it goes above 1, turn into 1. No, I want something cheaper, something that says, when this goes above 1, let's just stop here and assume that it's 1 and just clamp, not clamp the operations, but just stop doing operations until the value changes to something that it's not 1. So it's a cheaper way of achieving the clamp, essentially. And that's why we have the saturate node. So the saturate node is so cheap, in fact, that it's borderline free on most devices and shader models. As far as I know, this is the latest model of the saturate node is not available on all shader models. So, you know, potato, potato. But effectively speaking, in 99% of devices, this is free. So there's no reason really for you to use clamp over saturate. So look at this here. It's not bleeding colors anymore. It's the same thing as clamp. It's as good, just as good as clamp. Look at that, beautiful. So, all right. Of course, the difference between clamp and saturate is that when you clamp, you get to choose the values, right? You get to choose the values. Saturation, not so much. It's going to be 0 and 1, buddy. But, you know, if you need something like -1 and 2.5, then you can't saturate. So that's the only scenario where, realistically speaking, you're going to use clamp over saturate when you need to specify the values, which is not our case, not in this case specifically. So, all right, cool. So now we covered most forms of remapping stuff, right? So now let's try to apply this knowledge, right, a little bit. So, for example, one thing that we could do here that uses multiplication and all of that stuff. So remember, the goal of using the sine wave here is to explain the sine wave, what it does, and also use it as a way of like showing off other techniques. And one of them is 1-, and I personally really like 1-. So 1- essentially flips. You guys can see here that it's being flipped. So let's do a visualization on Desmos once again. 1 second. So let's do a visualization on Desmos here. So here we have our wave, right? Let me delete this point here. And let's just make it, you know, let's just keep it like that. Let's add a new expression here, which is going to be essentially our new point, which is O for 1-, is equal to S times -1. And look at that. Now we have the opposite of this. It's a mirror image, right? A better representation of this is this. So here we have x, which is just x going up, you know, a very simple function. And then we have x times -1. So this is what the -1 does, okay? Please remember, the -1 has some caveats. There are some times where -1 doesn't work perfectly, but those scenarios are very rare because they're usually like scenarios where, you know, you're messing with numbers for their values. Like, I don't know how to explain it, but if you use 1- and it doesn't work properly, it's probably because you have some sort of mathematical operation that requires you to flip things in the mathematical operation. So if we look in here, now, well, I can't really show because I don't have the default one, but here on these little screens, I think it shows perfectly what's going on, right? So when this one is black, this one is white. When this one is white, this one's black. All right, now let's do a little bit of a hands-on approach. So I'm going to show you guys, let me get my clouds here. I have a cloud texture. So I want to show you guys one of the most famous things in shader development, which is texture 1 times texture 2 times 2. So this is texture 1, this is texture 2. Now let's do the operation. So texture 1 times, aka multiplied, by texture 2. Now, anything multiplied by black is black, so anything multiplied by a value that's lesser than 1, it's going to be biased towards that value, meaning that intensity is going to go down if you have a grayscale image like I have here. So this is why we do times 2. Oops, multiply times 2. Why do we multiply times 2? Well, so this way we can double the brightness, right? So when we double the brightness, we somewhat get back the values that we had lost before. And you might look at this and you will say, well, Leo, that's not very impressive now, is it? I don't think this is impressive at all. But here's the thing. So we have done UV manipulation before, so let's do it again. So if I take my time node, and this is just a float that goes up and up and up. So let's add, you know, and let's get here a vector 2. Let's plug this vector 2 here. And let's put this into the tiling and offset. Oops, this is going to go into the offset, not into the UV. Now let's plug this here. Now, this is essentially going to go at a fixed rate, but we can mess with it. So we can add 4, oh, sorry, my bad. Should be a multiplication, because we're multiplying the rate at which this float goes up by each chassis. So we can do 1 and 1, which is the same, or we can do -1 and 1, for example. All right, cool. Let's Ctrl-C, Ctrl-V this up, and put this here. All right, cool. Now, what we can do is like do 1 and -1 here, so it goes in an opposite direction. And we can also mess with the tiling, which is how often the texture repeats itself. So let's do 0.2 here, and I don't know, 0.5 here. All right, cool. And now you guys can see here that the shape we have is considerably more complex. I mean, this might not look like much, but trust me, this thing right here is very complex for its cost, because all of these operations that we're doing are free, pretty much. So this right here is super cheap, and it's very complex for the level of complexity that we're getting. It's very cheap for the level of complexity, sorry. So another usage of the multiplication node is to mask things out. So if I have here my Leo texture, and I think I've mentioned this before, we can multiply it, and it's going to be masked. But guess what? This is a grayscale image, so I can also use the 1- to flip it over. So if I take this here, so now the Leo is in black, but I can flip it using the 1- node, and then when I do that, now the only part that's going to be visible with the noise is the Leo, thingy. All right, very cool. So I think this is all I had to cover. I'm not sure if I have anything else that I want to cover regarding this. I guess I also want to cover that, of course, you can do all of these operations with colors. This is something very important. So if I want to multiply this by a color, and I already have a color property here in handy, so this green color, you guys are going to see that my noise is going to be green. So very simple stuff. Alrighty, folks, I think that's pretty much it. Honestly, those concepts, they're very important, but they're not, that complex to teach. So yeah, I hope you guys enjoyed the video, and thank you so much for the support. The comments have been great. We've been getting a lot of love lately on the YouTube channel. And please don't forget to check out our game. This is Fight and Fall, a party brawler game that I'm developing alongside William. And it's a very good video game. You guys can play it. It's local multiplayer, but you can play it using Parsec or using the Steam family, the Steam Remote Play Together feature, which is also very cool. So you can play it online with your friends. The game is a project of love, and we put a lot of effort into it. So please check it out if you guys are interested. So thank you so much for watching. Goodbye. See ya.